Okay, today, guys, what we're looking at is what we call modeling. What we're going to call two-step equations. We've been dealing with one-step equations for 2 lessons. We did addition, subtraction equations, and what did we do yesterday? Multiplication, division. All right, guys, with any one of those 4 types of equations, don't we use a property? For an addition equation, what property do you use? Subtraction property of equality. For a multiplication equation, you use the division property of equality. Good. All right, what I want you guys to do is I want you guys to, I guess, even divide your desk in half. And you don't have to do it perfectly, but you have 2 halves. Now, what do you think the 2 halves are going to represent if we're dealing with an equation? 2 sides or 2 sides of the balance. Good. All right, listen up. This is what I want you to do. Yeah, here's my desk in half, so I couldn't show it to you.
Wait, we can draw on our desk?
No, please don't draw. Yeah, don't draw. Thank you for asking. Okay, this little piece right here, and I have a key over there on the whiteboard, but this piece is worth what according to my key? It's X. Okay, the pieces with an X through is worth an X. Now, what is X worth? We don't know. A number. I don't know what value it is, but it's a number. Now, the non-shaded smaller square is worth what? Positive 1. It's a positive 1. And the shaded little square is going to be worth negative 1. You guys see that? Okay, I'm going to do something here. I'm going to show a property here on this. You can call it an equation mat, but your desk is the equation mat. I'm going to show you here a property. I want to see who can get it. Okay, if I have on one side, what's that worth?
1.
Positive 1. And I have on the other side a
1.
Positive 1. What do you know about both sides here? They're balanced. They're equal. Good. That's totally correct. Okay. That is just an equality. I hope it's not too complicated there. Let me give you another one. If I have an X on one side and I have an X on the other side, what's that worth?
That's 2. But
It's just balanced. You have you have an unknown number here and the same unknown number here. Even though I don't know the number, it is balanced. Okay, here's, just say balance or equal. Yeah, equal either one. All right, ready? Here's what I'm going to do. Please don't call out the answer until I give you a little bit of time to process. If on one side I put a plus 1, and on the same side I put a negative 1, what is this side right here worth? Raise your hand. Give you some time to think. If I have a plus 1 and a negative 1 on one side, what is that equal to? Okay, on the count of 3. 1, 2, 3.
0.
0. This right here, guys, we call this, these two are canceling each other out. Which property says that a number plus its opposite equals 0? Finn?
Inverse.
Not inverse. Daniel? Identity property. Okay? These two right here just cancel each other out. It's almost like they weren't there. Do you guys get that? Okay, here's what we're going to do. We're going to start up with our first equation. 3x minus 2 equals 7. All right, I'm going to write this on the board. 3x minus, what did I say here? 2 equals 7. All right, thank you. 3x minus 2 equals 7. Now, guys, what does the equal sign mean?
They're equal to.
This is equal to that, right? And it's balanced, right? This is the half mark. Okay, so what I want you to do, sorry? Tomorrow we're going to go over the same process and we're going to write a lot of stuff. But here we're just modeling. All right, this is what I want you to do. On one side of your desk, I want you to put 3 X's. 1, 2, 3. And on that same side, I'm going to put 2 of these negative 1s. Right? 2 negative 1s, which would be negative 2. What do you think I should put on the opposite side?
7.
7 positives or plus 1s. All right, so I'll do that. 1, 2, 3, 4, 5, 6, 7. All right, so it should look something like that. And some of you are like perfectionists, you're like straightening them out, and I'm making them crooked because I can't straighten them out with. I want to bother you a little bit. No. Actually, how many of you are bothered by these being a little bit crooked? Okay. I proved in my other, good for those who are not, but I proved in my other class, my 8th graders, that you're actually not bothered by that. You think you are, you're making yourself bothered by it, and I'll prove it today to you guys. How many of you believe me on that? Okay, good. All right. So this one, you're probably like, thank you, Mr. A. Maybe some of you are like, wait, no. Now thank you, whatever. And then this side, you're thinking, I can't stand you, Mr. A. Why are you doing this to me? Okay, this is what I'm going to do. These two sides are balanced. And how do I know that? Because they are equal. But my goal in these problems is not to find out what this is equal to that. I want to know, my main goal is what's one of these worth. I want to know what is an x worth. But right now I have 3 x's and 2 negatives and then 7 positives. This is what I'm going to do. I'm going to use one of the properties and I'm going to say it out loud, then I'm going to demonstrate it, and then somebody tell me if I use the property properly. Okay, I'm going to add to this side 2 positives, and I'm also going to add to this side 2 positives. Is that allowed?
Yes.
What property is that? I added 2 here and 2 here. Okay, Finn's hands up. Not associative. It's simple, guys. I added the same thing to this side as I did to the other side. I think Daniel knows. Finn may know. Paul kind of knows. Paul wants to give it a try. Go ahead.
No.
I added the same thing to both sides. It's a simpler property, guys. It's one we looked at 2 days ago. Tucker? Not identity. Not inverse yet.
The addition property of equality.
It's the addition property of equality. Are you allowed to add the same thing to both sides? Yes. Okay, I did that, right? And you're like, why would you do that, Mr. A? Okay, look at this, guys. Look at my map. What do I have here? I have this pair and I have this pair. Do you know what these pairs are worth? 0. So I can take them out. They are out of there. But do you notice that I added 2 to both sides? What happens to the 2 I added on this side? They stay. They don't just leave. Okay. Did I get rid of those 2 negatives?
Yeah.
So I'm still left with these 3 x's. I don't want to know what 3 x is. I want to know what 1 x is. So I got to divide both sides by 3. So here's divide this by 3. You guys see it 1, 2, 3. And I'm going to divide this one by 3. So basically you get them into 3 groups. Okay. So listen. This side is divided by 3, and this side is divided by 3. And what is 3x divided by 3?
1. Wait, 3x is divided by 3x?
It's x. What's 9 divided by 3? 3. What is x worth? Oh, what is x worth? 3. Now, how many of you can see that x is worth 3? Like you can see it on my map. But listen up, guys. What did we say about all of these equation problems? You should be able to
do it algebraically.
We did it algebraically, thankfully. We should be able to check. Oh, man. All right. Yes, sir. Cam? Go ahead. Go. Yeah. Take care. All right. Here we go. We had 3x minus 2 equals 7. And what did we say x was? X is equal. That's what I think it is, right? So this is what I'm going to do. What's 3 times 3? What's 9 minus 2? Is 9 minus 2 equals 7? This is the correct answer. That checks. With this right here, I'm going to do more. You'll start seeing some more. All right, let's go back to it. Yes, sir?
Could it be worth 4 because 4 of these are 1 squares can fit into 1?
Okay, great question. Like, okay, this square right here, isn't it worth like 4 of these? Now, by size it is, but it's just because of size. I could have made this bigger or smaller. Don't look at the proportions of it. We're just looking at the actual numbers. Think of this as like a box. I don't know what's in it. All right, next problem we're going to do is 2x plus 3 equals negative 5. 2x plus 3 equals negative 5. Can you guys show that on your tables? Yeah, show it on your table. See if you guys get it right. 2x plus 3 equals negative 5. So I got 2x's on one side. And then on that same side, I add 3. And then on the other side, I have to put 5 negatives.
I did that the other way around. Is that still right?
Okay, is yours different than mine?
Yeah.
Okay, watch this. Ready, Finn? This is technology at its finest. Ready?
Oh my god. What is that? Oh my god.
What was that? Is that allowed to do, by the way? I know, that's hard. That's hard for you guys. But you guys see what I did?
I know, but like
It's the same thing. That property, guys, when you flip it around and you say the same thing but reversed order, you call it the symmetric property. It's the same thing. How many of you have it this way on your paper? Or, sorry, on your desk? How many of you have it this way? How many of you don't have it either way? You have it like this way. You're like, what's happening, Mr. A? Okay.
Whoa, Daniel.
I think Daniel's like, what's happening?
That's okay. Are you right?
Yeah.
Okay. Could have been leaning back too far. Is that... Okay.
No, I think it should
That's why I'm trying to protect you guys.
What's the just have not touching my stuff?
It's possible. All right. I have homework for you, but you guys don't seem to want it yet. You may want it right at the bell. I'll just give it to you at the bell. Okay, here's what I want to do, guys. My goal... Well, I don't mind waiting. I'm entertained. Okay. My goal is to find out what one of these x's is, right? So what I'm going to do is I'm going to look at the side with the x, or the two x's in this case, and you guys see these 3 positives. How do I get rid of them?
You add 3 negatives.
I'm going to add 3 negatives here. Now, you said something, Finn, that's actually very correct. What you do to one side, you have to do to the other.
So that means you
Did you get that?
Yes.
There you go. Yeah. Okay. Because we're using which property of equality?
Addition property.
Okay, guys, listen. Aren't these worth negative? Negative 1, negative 2, negative 3? You added negative 3, which is the same thing as subtracting 3. Same thing. And maybe some of you are like, huh? Okay, that's right. So what happens to this pair, and this pair? They cancel out. But remember, you had to balance it, so you had to keep it. Okay, so I have 2x on one side, which is awesome. But then I have 1, 2, 3, 4, 5, 6, 7, 8 negatives on there. What do you guys think you should do next? Divide by 2. All right, so I divide my groups into 2.
I don't understand how you got that.
Okay, do you guys see I have 2 x's here? And you see I have 8 on this side. So I'm dividing both sides equally by 2. So here, 1, 2. Because how many x's do I have? So that's where you divide. You don't want to find what 2 x's are. You want to find out what one of them is. Do you guys see this? And you guys see this grouping? Okay, we can eliminate that. And what are we left with? X equals negative 4. But I don't believe that because I'm skeptical. 2x plus 3 equals negative 5. What did we say x was?
Negative 4.
All right. What's 2 times negative 4? Negative 8 plus 3? Negative 5. Does that check?
Yes.
That's the answer. That's the missing number. Negative 8? Or I'm going to do it again. We're going to just keep doing this over and over. Yes, sir.
If you would have wrote that on paper, you could have solved it.
Yeah, we're going to do it with paper. We're not going to do it with these models, but we have to understand what's going on. Okay, this is what I want you guys to do. On your table, I'm going to give you another equation. You're going to model it for me one step at a time. I'm just going to run through and I'm going to look, are they doing it correctly? So the next equation we're going to do, 3x plus 4 equals negative 2. I'll get that, sorry. 3x plus 4 equals negative 2. Now this is what I want, 7th grade. I just want to see this on your desk. I don't want to get the answer. I'm not concerned with that right now. I need you to get this equation. 3x plus 4 equals negative 2. Some of you are getting there. Some of you got it. 3x plus 4 equals negative 2. Negative 2. Good. Good. Yeah, use your negatives and positives the right way. 3x negative 2. 3x negative 2. Yes.
On the last one, why did you add negative 3?
I'm going to do the same thing here. I'll show you why. Yes, sir? Yes. And you can have homework sooner or later based on how you do here. Okay. Most of you are getting it. 3x plus 4, right? Because it's 3x's plus 4 positives equals negative 2. Okay. All right. This is what you should have. Something that looks like this. 3x. I'm waiting for you guys to quiet down so I can keep going.
I think your screen's frozen.
Oh, yes. 3x plus 4 equals negative 2. So you should look something like that. It could look a little different, but it's the same idea. Okay. Some people are asking, Mr. A, well, okay, I get how to do this diagram. Most of you know how to put it. But what are you trying to do in this problem? Remember, what's my goal in these problems? I want to find out what one of these guys is. All right, but I have 3 of them plus 4 positives. I want to get rid of all that extra stuff. Okay, how can I get rid of these positive 4s, or this positive 4, using a property of equality? This, Jack?
Add 4 negatives to each side.
I'm going to add 4 negatives to each side. And you're like, why 4 negatives? Okay, first why 4, and then why negatives? Does anyone know how to explain why did we add 4 negatives to both sides? Like, that seems kind of random. Avery? Yeah, that doesn't sound good. Better fix that. Okay, you see this pair? I'm pointing to this pair, this pair, this pair, and this pair. What happens to those? What are these worth? What's 4 positive plus 4 negative? 0. You might as well get rid of them. Everyone see that step? That's super important.
Like, can I say what we did a couple days ago?
This is very similar, but it's a 2-step one, so it gets a little more complicated. Okay. Now, how many x's do I have here?
7.
Because I added 4 negatives here. I have to add 4 negatives here. I have to keep it balanced. So if I put 4 here, I got to put 4 on the other side to keep that balanced. Okay. If I have 3 x's here, how do I divide this so that I only have 1 x? Divided by 3. I'm going to divide this by 3. 1, 2, 3. And divide this by 3. So what is each x worth?
2. Negative 2.
Good. Negative 2. Negative 2. So x is equal negative 2. I'm actually going to have you guys work in pairs. Ellie, are you kind of getting this? Well, 2 brains are better than 1, so that'll help you out. And then I'll be around. What did we say x equals?
Negative 2.
I'll wait. Okay, I'll do this. Next time I have to wait, you're going to wait 5 minutes with me after class. I mean, listen, guys, some of you are doing well. You're just sitting there waiting. And then others of you think it's social time every time I turn my back around. And then social time is being lost for break. So it's your choice. I'm not forcing you to do either one. Okay, 3 times negative 2. 3 times negative 2. Negative 6 plus 4. What does that get me? Is this the answer? It checks. Okay, this is what I want you guys to do next. With the person next to you, or you can work you 3 right there, and I think everyone else is good. With the person next to you, or in your group, you guys are going to model, each one of you is going to model, not just one of you, 4x minus 3 equals 9. 4x minus 3 equals 9. Just go ahead and model that One side you have 4x minus 3, and the other side you have positive 9. So show that. How many x's should go on this side?
This split part is one person doing.
No, you're both doing it, but you're going to check each other to see if you're right. Yeah, good. Your pencils are showing that. Yeah. So 4x minus 3 equals positive 9. And check your neighbor, the person you're working with, and see, do we have the same thing? Or are we both wrong? Or both right? Or one of us is right, one of us is wrong? I don't know.
Doesn't matter what order you put in.
That's a good question. What do you think?
No.
Because of which property?
The symmetrical thingy.
Are you talking about like they're flipped?
Yeah.
Okay, it's symmetric property. What if I did this? Look, ready? I'm going to mess yours up. Hopefully not too bad. Is that loud? Ready? Is that loud? Yeah. I'm going to mess yours up just a little bit. Ready? Is that loud?
Yes.
Okay.
Don't mess mine up.
Is that loud? Is that allowed?
Rose will freak you to touch me.
Oh, no, I will touch it because you want to get used to seeing it in different ways. Sorry. Yeah. Yeah, no one else has to touch it. Let her be. All right, how many of you think you're good on the 4x minus 3 equals 9? Okay, one person at a time, go through the process of what you're going to do. So if it's between you two, you figure out who wants to go first. You choose. Who wants to go first? You choose. Sorry, that messes things up. And I'm walking by. So your goal, ladies, is to get this by itself, right? But isn't it all have all this extra stuff with it? So what do I deal with first? Okay, and then here, do you guys have the same thing on there?
No.
So who's right?
I don't know.
Figure it
I'm
out.
probably wrong.
But why?
Because I'm probably wrong.
Okay, Chloe, look at the half line. This is half line, right? What should you have on one side? 9? What should you have on the other side? 4x's minus 3. So yours is good. Because it says right there 4x minus 3. Oh, you put 3 negatives. So 4x minus 3. Yep, equals 9, right? Is that 9?
1, 2, 3, 4, 5, 6, 7, 8. Yes.
Okay, now your guys is flipped, but is that allowed? Yes. Okay, so one of you figure out. I think you said what to do first step, Ellie. Did you guys figure it out?
Positive.
Positive 3, good. Did you guys figure it out?
Yeah.
All right.
Show me the
Yeah, solve it. Both of you do it one at a time. So like Cam can do it first, Avery watches, Avery does it second, Cam watches. Do you guys get it? Show it to me. Start it up. No, I want the model, the whole thing. 4x minus 3, okay? All right. I'll be right there. Sorry, guys. So what do you do from there? Sorry. Is this 4x? And then that's 3, right? Okay, Elijah's showing me. Oh, yeah, good. You add 3 to both sides. You understand I'm going to call one of you up there, right? And I want it modeled properly. You can save your classmates some homework or add to their homework load. All right, question? Yeah, solve it. One at a time, though. Yeah, one at a time. So you do it first, you watch. You do it next, you watch.
Does x equal?
You can check it, right? See if it works.
Don't we have to add negative 3 to both sides?
Not add negative 3, but positive 3. Because don't you already have negative 3 here? So in order to cancel that, you add 3 here and add 3 there.
Okay.
And then that'll cancel that out. And then divide out.
No, watch. You did
little chipmunk video.
Mine doesn't work. Mine is
Oh wait, no, not a video.
just like
Good. Yes.
4x, negative 3, and then 6, and then x. Over
Like
there.
that. No, because x equals 4.
Well, we don't know what x equals right now, so don't model that yet. I don't know what, so don't put that. Put the 9 positives in. Okay. Yeah. So listen, this number, it could be anything. Until you solve it, you don't know what it is. It could be 10 or 10, negative 5. I don't know. Depends. Okay. I'm going to give you one last one. And this is what I want you to do. In the same groups, I'm going to have you work it out one at a time. Then I'm going to ask one person from each group to model it for me. If it's not right, your group gets more problems for homework. Simple? Because you need more practice, right? So listen to me carefully. I'll give you time to work it out, and let's say one of you doesn't get it, you can ask the other person, how do I do it? And then when Mr. A comes, if I pick the person who didn't get it, they'll be more ready. And again, it'll be for your group, so it could be you three or every other pair. Okay, here's a problem. Sorry? The whole process. I want to see the whole process. Okay, the problem is negative 6 equals 2x minus 4. Yep. Negative 6 equals 2x minus 4. So I'm going to give you just a little bit of time to practice it. Then I'm coming around to ask one from each group. Set it up, do it, and then get ready to set it up for me because I'm going to ask one of you to do it. So after you do it once, set it back up because I'll ask you possibly. Your probability of getting chosen is 50%.
So Mr. A, what's the problem? It's on the board.
Negative 6 equals 2x minus 4.
I did it. A very positive.
Yeah, you do it, make sure you get it, and then set it back up because I'm coming to check. Reset it, and I'm coming around to start checking in about 1 minute. 1 minute, and then I'm checking. Yes, sir?
Okay, we did it now.
Set it back up, and be ready for me to ask you for it.
So I get 2x means like 2 of these x's, right? And then minus 4.
Yes, so 4 negatives.
4 negatives, got it.
Hold on. All right, listen up. This is what I want you to do. Because it takes a little bit of time for me to ask different groups, while I'm asking, the one that I just asked you for, everyone else can be working on this other one. So this one is a different one, but this is practice. You guys do it while I'm asking. How about this? I'm going to start with this row right here. So these two groups, you should be working on this new problem, but be ready for the old problem. Okay, I'll give you guys 3x plus 4 equals 10. 3x plus 4 equals 10. Okay, that's you guys. I'm asking you now for the original. Okay, Olivia, model it.
Okay.
Negative 2x minus 4, negative 6. Go ahead.
So negative 6 equals 2x minus 4.
Mm-hmm.
So you're trying to cancel these out, so you would add positive 4 to both sides.
Okay. First step is good. They stick together, huh? Okay.
So then
Great.
these would all cancel
All right.
out. And then these would cancel
Oh.
out. And that would leave these two.
Uh-huh.
So x equals negative 4.
Very good. Okay, Daniel, model it for me.
Good job.
So you got 2x minus 4, negative 6. All right, go ahead.
Okay, so you have to like minus that.
And then start working on that one up there.
So you add these 4 to both sides. And then so those go away. That cancels out. Same with 4 of those.
Oh, those cancel out too. Okay.
And then so you get x equals negative 1.
Yes, sir. Yes, hurry. You got it. Will, model it. You can use that. You can use this if you want.
Okay. So 2x plus negative 4 equals negative 6.
Yeah, and then show me the problem. Like, work it out.
Oh, okay.
What do you do?
So you add 4 to this side to cancel these out, and then you add 4 to this side to cancel these out. Take these out, figures out, bring this back, and then you divide it by 2, and x equals negative 1.
Good. Okay. Go ahead and do the problem up on the board. The 3x plus 4.
Do it when you come over here.
All right, this middle section, get ready to show me negative 6 equals 2x minus 4. You guys can finish that one up or just wait. You guys should be doing 3x plus 4 equals 10. No. Emma. Yep.
So you have the 2x. And you have minus 4.
Sometimes I think about it.
So be ready, guys, when I come to get that. Be ready to get that one on there.
Then you add your positive 4.
Okay. Emma, you were gonna do the balancing of 4, which is good. Oh, time runs out. I'm going to take away the homework for tonight, but you guys need to pay attention. We're gonna be doing this type of problem with no manipulatives tomorrow. And you're like, yes, I feel like you get it. But we're gonna refer to these. So if you guys take those pieces and put them in the recycling. Don't smash them up either. No.
That's a good idea.
No. I want them to cut it out because it'll help them to know what they're doing. Some pieces are missing. Yeah, you throw them out.
I know how to do this now. I understand that. I just don't know if I can do it without these. Yeah.
No, and that's okay. So if you get this, we're gonna move from that tomorrow and see if we can do it without them together.
Was the answer negative 1?
Yes.
Yes.
So what did it take to get it? So, yes, and the other P word, practice. Imagine that.
And Ellie.
And